Today, I'll be sharing with you a brief, opinion piece that I wrote for Frontiers in Marine Science called The Plastic Cycle, an Unknown Branch of the Carbon Cycle. So plastic pollution is an emerging contaminant that is pretty much ubiquitous in all around the world in terrestrial, freshwater, and marine ecosystems. Its risks are poorly understood, unfortunately, especially for microplastics, which are plastic less than 5 millimeters in diameter. However, due to its ubiquity, the huge volume in which it is entering the environment, we need ways to control this contaminant. And to help us answer these questions, there's a lot of gaps in the field right now, especially when it comes to where it ends up and how it's transported through the environment. We need to better understand this, first of all, the fate, in order to determine exposure concentrations, which is relevant for risk assessment, but also to inform mitigation strategies and environmental remediation strategies. So how might we describe the cycling of plastic in the environment? There's another idea that I've been thinking about for a very long time about the fact that we're producing so much plastic from basically the fossil carbon reservoir, which is a huge reservoir of carbon underground that is hundreds of millions of years old. And we know that plastic polymers, the majority of them, are made from fossil fuels. So how does plastic fit into the big picture of carbon cycle? So the arguments and the ideas I'm exploring in my opinion piece are, first, how might we describe plastic transport in the environment? I propose that we use biogeochemical cycling terminology to describe the cycling of plastic in the environment. So here are the reservoirs of plastic that are of great interest to the plastic pollution field. And there are also fluxes of plastic that exist. Flux is the movement of particles from one location to another over a certain period of time and area. Sorry, I forgot to define reservoirs. Reservoirs are temporary places of storage of plastic, like how you have carbon reservoirs. You can also have those for plastic. And fluxes, you have fluxes of carbon or nitrogen or phosphorus. You can also describe plastic this way. And this framework together, the fluxes, the reservoirs, and the important rates like fragmentation, stuff breaking down into smaller pieces, and mineralization, all this describe the global plastic cycle, which is a huge unknown. There's a lot of parameters to quantify. So far, we only know the ocean surface reservoir really well as the terrestrial ocean flux. And the second argument that I'm interested in exploring is, how does plastic fit into the big picture of carbon cycling? So this is a diagram of the carbon cycle with its reservoirs, its stores of carbon, as well as the fluxes. And the fluxes are in yellow and the reservoirs are in white. And then we have anthropogenic impact in red. So every year, roughly 9 gigatons of carbon are released into the atmosphere. But then what's really not well understood is how plastic moves carbon. So the movement of plastic in the soil, and plastic settling to the bottom of the ocean, and plastic fibers and fragments being resuspended in air, those are also moving carbon as well because they're made of fossil carbon. So there's a lot of gaps to fill in this field, but by using a framework that's similar to biogeochemical cycles, we can help to fill these unknowns. And future research should fill the unknowns in the global plastic cycle, as well as investigate how plastic moves carbon throughout the environment and the interconnections between plastic pollution, carbon cycling, and climate change. So thank you. And if you have any questions, please let me know.
Thanks, Alice. We'll be taking questions now. Feel free to raise your hand or ask your question in the chat, and I can read it out loud. I think Jeff has a question.
Yeah, so I was wondering, because there's a lot of stuff in the news about microplastics. and
Yeah.
microplastics getting in our food. Do we know anything about how, like, just the process of breaking down plastics into microplastics might be like kind of contributing to this plastic cycling?
Yeah, absolutely. So, me having a chemistry background, I usually prefer to focus on mass of plastic over count. But in ecotox, people love the count measure because it's like, oh, this animal ingested 5 pieces, 10 pieces, and it was the 5 pieces that, killed them. So microplastic is definitely something that might not contribute as much to mass, but well, the primary microplastic, but microplastic can come from big objects over time. They fragment over time. Sorry, long-winded explanation, but basically, there are a lot of people studying microplastic right now, trying to figure out how toxic it is and the chemicals associated with it. And the short answer is we still don't really know how toxic they are, because the lab results give different answers depending on what organism you test and also how the plastics are shaped. Like spheres are not as toxic as fragments, which are sharp and jagged, so they're more likely to like pierce the stomach lining. So there's definitely a lot more research to be done on that, but definitely they're part of the plastic cycle because they come from the fragmentation of larger objects. Yeah, so we can't ignore them.
Perfect, thank you.
No problem.
So Natalia also has a question, and just a heads up, there's the judging form for Alice in the chat. Go ahead, Natalia.
Thanks. Thanks. This is a very interesting point of view, and what I wanted to ask is the reason why you think we should include it